Hi everyone, in this video we will have the 4 differentiation rules, the first 4. Okay, rule number 1, the constant rule. The derivative of a constant is 0. So the derivative can be interpreted as the slope of the tangent line and the tangent line at a horizontal line, because the constant function is the graph is a horizontal line, so the slope of the tangent line is also 0. For example, we have f of x equals 3. The derivative of this is 0. So the derivative of 3 is 0. Let's say g of x equals negative 10. That's another constant. So g prime of x is 0. The derivative of 9 with respect to x is also 0 because 9 is a constant. And the derivative of pi with respect to x is also 0. So as what you can see here, if we are given with a constant function here, the derivative is 0. The derivative is 0 here. A different notation for derivative. So the derivative of a constant 9 is also 0. The derivative of pi is a constant, approximately 3.14, is also 0. Okay, let us have rule number 2, the power rule. So this is what you often use in differentiating functions. If a function is in the form x raised to n, or if f of x equals x raised to n, then the derivative of f of x, or f prime of x, is equal to nx raised to n minus 1. So as what you can see here, the exponent n is going to be a numerical coefficient here, and the exponent will be deducted by 1. So what you're going to do is make the exponent the numerical coefficient and subtract 1 from the exponent. So this is derived. This can be derived by using the limit definition of the derivative and applying the binomial expansion. For example, f of x equals x squared. So our n here is 2. So 2 is going to be a numerical coefficient. So that's going to be 2 times x raised to 2 minus 1. So the exponent here is going to be 2 minus 1 because that's n minus 1. And that 2 minus 1 is 1. So that's going to be just simply 2x. How about if we have x cubed? So n is 3 here in this case. So the derivative is make 3 a numerical coefficient here, and then subtract 1 from 3, you will get 2 to the exponent here. The derivative of x raised to 4 is 4x cubed. Make 4 the coefficient and subtract 1 from 4, you will have 3. So 4x cubed. And the derivative of x raised to 5 is 5x raised to 4. The exponent 5 will become the numerical coefficient, and you subtract 1 from 5, you will get 4. So 5x raised to 4. Okay, how about the derivative of x? So x is x raised to 1. So you will make, so our n here is 1. So 1 will be the numerical coefficient. And then if you subtract 1 from 1, you will get 0. And x raised to 0 is 1. So 1 times 1 is 1. So the derivative of x is 1. How about the derivative of x raised to 6? Make 6 the numerical coefficient and subtract 1 from 6. You will get 6x raised to 5. How about the derivative of x raised to negative 3? So make negative 3 a numerical coefficient and subtract 1 from negative 3, you will get negative 4. Or if you want to have a positive exponent, just put x raised to 4 to the denominator and you will have a positive 4 for the exponent. How about the derivative of 1 over x squared? 1 over x squared can be written as x raised to negative 2. And then it's already in the form x raised to n, where n is equal to negative 2. So negative 2 will be the numerical coefficient. And you subtract 1 from 2, you will get negative 3. So negative 2x raised to negative 3. If you want a positive exponent, then you can put x raised to negative 3 to the denominator, and that will be x cubed. How about the derivative of square root of x? Square root of x is the radical form, and its exponential form is x raised to 1 half. So our n here is 1 half. So 1 half will be the numerical coefficient, and then copy x, and then 1 half minus 1 is going to be negative 1 half. If you want to put this in the denominator, that's going to be a positive 1 half, and a positive 1 half exponent is going to be a square root. How about this? The derivative of x raised to 2/3. So the derivative of x raised to 2/3, that's also x raised to n. Our n here is 2/3. 2/3 will become the numerical coefficient, and subtract 1 from 2/3. So 2/3 minus 1 is negative 1/3. So you will have 2 over 3x raised to 1/3. Or if you want it in radical form, x raised to 1/3 can be written as cube root. So if you want a radical form, so this is going to be 2 over 3 cube root of x. Because x raised to 1/3 is cube root. So 2 over 3 cube root of x. Okay, let us have rule number 3. So in this video, we will only have rules 1 to 4. So rule number 3, the constant multiple rule. If f of x equals k times h of x, where k is a constant, then f prime of x is equal to k times h prime of x. Meaning to say, if you have a multiple of a function, then you can just put that constant multiple outside, or you can take the derivative of the function and multiply to the constant. For example, f of x equals 3x. So this is a constant multiple of x. So 3 times x. So the derivative of that is you just copy 3 and then take the derivative of x. And that the derivative of x applying the power rule is 1. So that's going to be 3 times 1, which is 3. So the derivative of 3x is simply 3. How about the derivative of 2x squared? So you can just multiply 2 to the derivative of x squared. So 2 times the derivative of x squared, or this is going to be down here, not an exponent. So g prime of x is equal to 2. This 2 is, you just copy this one. And the derivative of x squared is 2x by applying the power rule. 2 will be the numerical coefficient, and subtract 1 from the exponent. So this is 2x raised to 1. So 2 times 2x is 4x. So the derivative of 2x squared is 4x. And the derivative of negative 4x cubed, you just copy negative 4 and take the derivative of x cubed. So copy negative 4. This is the constant multiple. And then the derivative of x cubed is 3x squared by applying the power rule. So negative 4 times 3x squared is negative 12x squared. And lastly, the sum rule. If f of x is equal to g of x plus h of x, where g and h are differentiable functions, then f prime of x is equal to g prime of x plus h prime of x. Meaning to say, if you have a function expressed as a sum of two other functions, the derivative of the function is you just take the derivative of the first and then take the derivative of the second and you add them. Or if this is minus, it's also going to be minus. And then this can also be extended if you have more terms. Let's say you have 3 terms, 4 terms, 5 terms, and so on. So this still applies. For example, f of x equals 3x plus 1. So we have two terms here. We have 3x and 1. So if you get the derivative of f of x, get the derivative of 3x and get the derivative of 1. So the derivative of 3x is 3 and the derivative of constant is 0. So 3 plus 0 is 3. How about of g of x? G of x equals 6x squared minus x raised to 5 expressed as um, a difference of 6x squared and x raised to 5, or it can also be interpreted as the sum of 6x squared and negative x raised to 5. So we can apply here the sum rule. So the derivative of 6x squared is 6 times 2x. That is 12x. Because the derivative of x squared is 2x. By applying the power rule and according to the constant multiple, we will just multiply it to the multiple here, 6. And then the derivative of x raised to 5, applying the power rule, is 5x raised to 4. So just copy negative, minus the minus sign. So 5x raised to 4. So the derivative of 6x squared minus x raised to 5 is equal to 12x minus 5x raised to 4. How about this? We have four terms here. The derivative of x raised to 6 minus 4x raised to 4 plus 2x minus 8. So get the derivative of each term according to the sum rule. So the derivative of x raised to 6, applying the power rule, is 6x raised to 5. The exponent 6 will be the coefficient. Subtract 1 from the exponent. Minus the derivative of 4x raised to 4 is 16x cubed. The derivative of 2x is 2. And the derivative of a constant negative 8 is 0. So no need to write that. So the derivative is 6x raised to 5 minus 16x cubed plus 2. Okay, for your exercises, we have here 4 items, but in the 4 items, there are several terms. So you differentiate each term here. And if you need more time, then pause the video. So by the way, if you haven't subscribed yet, please click subscribe button there. And to support FatMath, yeah, please watch the videos. So for my contents, we have here different subjects or different math subjects in high school. We have grade 10 mathematics. We have basic calculus, pre-calculus. And so far, that's all. And we have also general mathematics. And hopefully later on, we will have all the mathematics subjects in high school, including statistics and probability and the other maths for other grade levels. So as of this time, we only have contents for grade 10, pre-calculus, basic calculus, and general mathematics. So try these items, and I will reveal the answers in a few minutes. So by the way, thank you so much to my supportive students at Leganes National High School. Okay. To the STEM students of grade 11 Wisdom and Courage, this one is for you. And for other students from the other schools, you can also use this as your reference or as a reviewer if you have your exams. Okay, so let's reveal the answers for number 1. Okay, what is the derivative of 3x raised to 10 minus 6x raised to 7 plus x raised to 4 minus 1? So that is 30x raised to 9. So that's the derivative of the first term. The derivative of this is negative 42x raised to 6 plus 4x cubed. The derivative of negative 1 is 0. So did you get the correct answer? Comment down below. Number 2, negative 2x raised to 9 plus x raised to 5 minus 1 half x squared. So the derivative of that is negative 2 times 9x raised to 8. So that's negative 18x raised to 8. For this one, 5x raised to 4. And then for negative 1 half x squared, 1 half times 2x, that is x. So minus x. Number 3, we have 1/4 x raised to 8. This is going to be 1/4 times 8 x raised to 7. So 1/4 times 8 is 2. And then 2/3 times 6x raised to 5. 2/3 times 6 is 4. So 4x raised to 5. 2 times 3x squared, that's 6x squared, minus 7. And then the derivative of 8 is 0. So this is the answer. Okay, for number 4, I of x is equal to 4x raised to 5/4 minus 3x raised to 4/3 minus 14x raised to 2/7. So the derivative of that is this one. So for this first term, 4 times 5/4 is going to be 5. And then subtract 1 from 5/4, that's going to be 1/4. Minus 3 times 4/3 is 4. And then 4/3 minus 1 is 1/3. Minus, for this one, 14 times 2/7 is 4. And then 2/7 minus 1 is negative 5/7. So this can be your final answer. So if you want a positive exponent here, you can put x raised to 5/7 at the denominator. And the exponent will be positive. So that's it for this video. Please like and subscribe, FatMath. Bye!